So today we're going to talk about prime numbers. A number is prime if its only divisors are 1 and itself. So for example, 11 is a prime number, whereas 9 is not a prime number. 9 can be factored into smaller parts, 3 times 3. Similarly, 15 is not prime because it can be written as 5 times 3. What we're going to show today is a very basic fact about prime numbers, very easy fact, but very fundamental, which is the following. It's that every number can be written as a product of primes. Now this is easy enough to see for small numbers. You know, look at something like 2, 3, 4, right? 2 is already written as a product of primes, so it's 3. 4 is 2 times 2. 5, 6 is 2 times 3. So we can see for small numbers that they can be factored into primes just directly. Can we tell that this is true for every number? Well, suppose n cannot be written as a product of primes. So suppose there's a number that can't be factored in this way into primes. And moreover, if there's a number that can't be written in that way, and there's a smallest number that can't be written in that way. So let's suppose n is the smallest such number. So we're going to try to find a contradiction from this. We have a number that we're supposing can't be written as a product of primes, and it's the smallest number that can't be written as a product of primes. Well, n can't be prime. If it were prime, it would already be written as a product of primes. So n is composite, the opposite of prime. That means that n can be written as a times b, for some smaller numbers a and b. Now, since a and b are both numbers that are smaller than n, that means that they can be written as products of primes. So we have a is equal to p1 times pk, and b is equal to q1 times ql, where all these p's and q's are prime numbers. So this is the prime factorization of a and b, respectively. And we know that exists just because we chose n to be the smallest number that can't be factored into primes. But from this it follows that n is equal to p1 up to pk times q1 up to ql. In other words, the fact that we can factor a and b into primes tells us that we can factor n into primes. So there really can't be any number that can't be factored into primes.